Okay, hello everyone. So what today we are going to do is we are going to continue with the application part. And before do that, let me write the formula of any given, that is calculus of a variation, that is in general it is any integral of y of x over the interval x1 to x2. F is a function of x, y and y prime into dx, right? And to which I need to find my solution curve, that is y is equal to y of x. So yesterday we have done a problem on, that is the geodesic. Okay, it is the shortest length between 2 points on the surface. Now suppose this is my point A, this is my point B. Let us consider this as x1, y1, and this as x2 and y2. So the shortest distance between the points on a surface is always what? It is always a straight line. So you need to take yesterday we have proved that the shortest distance between any 2 points on the surface is always a straight line. We have also proved it further with respect to slope point form also. You will get the same answer, and finally we have got the answer, that is y is equal to mx plus c, right? So let us see one more example. That is second example, that is find the geodesic on a surface given that the arc length of the surface is, that is S is equal to, that is x1 to x2, that is square root of x1 plus y1 square into dx, right? So here, so solution, I am going to write the solution here. Here f function of x, y and y prime is equal to, that is square root of x1 plus y1 prime square, right? So here also we know that by Euler's equation we have, so by Euler's equation we have, that is dou f by dou y minus d by dx of dou f by dou y prime is equal to 0. Therefore this time I will do it directly. So dou f by dou y, so let me consider this as my equation 1 and this as my equation 2. So directly this time I will do is dou f by dou y. So since this turns out to be 0, so minus d by dx of, so dou f by dou y prime it is, okay. So this is a composite function, so this is nothing but, this is minus, so this turns out to be d by dx of, I will write this in the bracket, right? So this is dou f by dou y prime, it is 1 upon 2 root x plus x into 1 plus y prime square, right, into dou by dou y prime of, see here it is 1, so here it is x into y prime square. Fine. So this, because here this turns out to be 0, here it is x is a constant over here, so minus, which is equal to, it is 0, so here it is minus d by dx of, inside the bracket, so here you can write if you differentiate this with respect to y prime, so this becomes x, that is 2x y prime, so here it is 2x y prime divided by 2 square root of x 1 plus y prime square, okay, which is equal to 0. Now this 2 and this 2 gets cancel, and if you take that is, this x can also be written as that is x, you can write it as root x into root x, so this again if I rewrite this, so which implies that is d by dx of, inside the bracket, that is root x y prime divided by, that is square root of 1 plus y1 prime square equal to 0. Therefore on integrating, we have, that is square root of x y prime, so when I integrate this, okay, so y prime divided by square root of 1 plus y prime square is equal to c. Now this equation I take it towards the other side, so here it turns out to be square root of x y prime, which is equal to c square root of 1 plus y1 prime, that is square. Now here if I take again if I square, so square on both sides, therefore on squaring, if I utilize this side board, okay, so therefore on squaring I will have, let me check, yes, that is x y prime is equal to c square inside the bracket 1 plus y1 prime square, right? Then yeah, this also turns out to be square, this is y dash square, fine, because I am squaring it. Now so here x y prime square, which is equal to c square plus c square y1 prime square. So what I'll do is, I will take this in common, that is x y prime square minus c square y prime square is equal to c square, right? Now here y1 prime square and y1 prime square, I take it common outside, so here I am left out with 1, that is x minus c square, which is equal to c square. So y prime square is equal to c square divided by x minus c square, right? Now again if I take square on both sides, so this turns out to be y prime is equal to, that is c divided by square root of x minus c square. Yes, now it is independent. Okay, so now what I do is, so question is understood, okay, I'll explain this. So the given equation, so this time I have done it directly. So this is the Euler's equation, you are given functional, evaluate it, it will turn out to be an ordinary differential equation, then make use of all previous method to solve it, and then it is y prime of c divided by square root of x minus c square, right? Now then, therefore Therefore, on integrating, that is y is equal to, that turns out to be c, integration of 1 divided by square root of x minus c square into, that is along dx, right, dx plus, I hope it is, yeah, c1. Now if you put x minus c square is equal to t, yeah, correct, yeah, fine, it is square root, yeah. So this turns out to be differentiating with respect to t, then this turns out to be, that is dt, right. So here y is equal to c integration of 1 upon t power 1 by, this turns out to be 1 by 2 into, that is dt plus c1. So y is equal to, this turns out to be c integration of t raised to 1 by 2, that is minus 1 by 2, okay, and into dt plus c1. So here it is y is equal to c, that is t raised to minus 1 by 2 plus 1, it becomes 1 by 2, okay, divided by 1 by 2 plus c1. I hope it is correct, yeah, fine. So now this 2 I am going to write here again. Therefore y is equal to, that is 2c t power 1 by 2 plus c1, right. Now here it is y, I hope I have to write, yeah, y is equal to, that is 2c, this is square root of, what is the value of t, value of t is, that is x minus c square plus c1, right. Now again what I do is, I take this equation 1, y minus c1, which is equal to 2c, that is if I square it, this turns out to be 4c square into x minus c square, sorry, I have already done, yeah. So this turns out to be, that is 2c square root of x minus c square. Now when you square this, so when you square this, 1 minus c1 square, which is equal to 4c square x minus c square. Is it not, what type of equation this is, if you have a good observation? So this, the required curve is, therefore the required curve is a parabola, right. So this turns out to be a output, fine. So geodesic problem is over. Now we shall move on to one more important concept, that is catenary. So what do you mean by catenary? So yeah. So what do you mean by catenary? So one more example, that is application part I will take, that is catenary problem. So geodesic problems are over, and you know what is geodesic. Now what is this catenary? So in short, catenary problems are very important, right. So what is this? It is a curve, that describes the shape of a flexible chain. So curve which describes shape of what type? Of flexible chain. Now why is it, why this particular thing is important? Okay, now this application you have so common catenary and catenary, which I have also told in my one of that is video lectures. So see here, you people travel, you go for outing and all, but what do you do when you travel outside? If you have a good observation, or nearby your house. Okay, see the electric poles. Suppose this is the electric poles, right? I'm not that good at drawing, right? So these are the electric poles and the cables are connected like this, right? Fine. So what is this? This is nothing but these are the curves describe the shape. Okay, so because of this uniformity, and see the distance of the pole from year to year, right? So that has been done by variational problem. Now at any instant, so this type, okay, or else you go for some park, right? So there are certain chains hanging, right? Okay, at uniform distance. Suppose this is a grill, and if you go to see like this, the chains are attached so that nobody crosses, no vehicle should pass from it. So this type of curves are nothing but they are common catenary. So it is equally, it is equally distributed. But what happens? There are certain problems. There are certain problems when you go to a ghat section. So how do you see if you see an observation, so some of the electric poles are here. So this is your road, and somewhere there is an elevation here, and this is the electric pole, and here electric pole, and these are the wires which are hanged, and this, suppose this is, if it is 30 feet pole, this is also 30 feet pole, but when it comes to the slope here, so there you do not have the uniformity, and here the this, what do you say, the wire is put with some tension and along the that is force of gravity downwards. Okay, so sometimes you have that is common catenary problems, and sometimes this catenary is nothing but what do we do is it describes the shape of a flexible chain. So this type of example you solve with the help of that is variational problem, that is calculus of variation, keeping in mind that is making use of Euler's equation, right? So let me have a problem. See, geodesic problems are over, catenary problems is over. No, catenary problem, I am doing it now. That is, prove that catenary is the curve which, when rotated about a line, generates a surface of minimum area. So let me write the description first and then explain you. So proof or the solution you can write. So we have the expression, you can write it in your own words, there is no problem, of the total surface area given by that is integration of 2 pi into ts, where the curve is rotated about the axis, about the x-axis. Okay, so this see what is being asked, that is prove that the catenary is the curve which when rotated about the line generates a surface of minimum area. So minimum area, okay. So what I do is I will draw a graph. So this is Z, Z is 0, okay, this is Y and this is X. So I generate my that is the curve here, okay, and generates the surface of minimum area, and it is rotated. So what I'll do is I will take a curve, simply a curve like this, and I will name it as A and B, and let the points of A be x1 and y1. You can take it as P, Q, any other way, alphabet you can take, and this is x2, y2. Okay, now this setup is over. Okay, so this is my curve S, right? This is my curve S, this complete curve, and when rotated about the line, okay, line generates a surface with minimum area. So when what I do is I take this curve and if I rotate it, okay, so what will happen? If I rotate this, this will turn out to be like this, yeah, about this along X. So if I take some part of this, right, of this curve, so if I take some part of this, this turns out to be ds. If I take some part of this, this turns out to be dx. If I take some part of this, this turns out to be dy. Fine. Therefore, I, that is the integral I, is equal to integration from x1 to x2 2 pi y, and see here, so ds, okay, so along what axis you are taking, that is it is generating along x. So what I do is, so I will write it as dx by dx. Some part I am taking of this curve, that is S, that is arc length. So this is ds by dx. So what is ds by dx? So which is equal to integration from x1 to x2 2 pi y. What is this? Derivative of an arc length, which I have already told you. It is and to which the given functional is minimum, and it is always given by, that is 1 plus y1 prime square into dx. Okay, so now here 2 pi is a constant. So right, since since 2 pi is constant, okay, so what I do is here this time f of x comma y prime is equal to, what is my function? So here it is y square root of 1 plus y 1 prime square, right? And for convenient purpose, also we know that by Euler's equation, that is my equation 3. See here, this equation I am taking, that is for my with my convenient purpose. I have given 4 forms of Euler's equation, right? So one of the forms of Euler equation, if you see, if you check, it is equation 3, that is given by, that is d by dx of inside the bracket f minus y prime dou f by dou y prime minus dou f by dou x equal to 0. Now we are in this equation, so I have written here, okay. Now in this equation, see here, you do not have x term, so obviously this will turn out to be 0. Therefore it is d by dx of inside the bracket, this is f y prime dou f by dou y prime equal to 0. Therefore on integrating we have we have f minus y prime dou f by dou y prime equal to 0. Now substituting for the value of f, so if I take the value of f value is, that is f is a function of x by y prime, it is y square root of 1 plus y1 square minus y prime. Since I have taken integration here, there is one more value, that is I am taking it as c. So dou f by dou y prime. So dou f by dou y prime. So if I am evaluating it, so this is constant. So I am writing it as so y into, that is square root of 1 plus y1 prime square. So this turns out to be that is y divided by 2 root 1 plus y prime square into dou by dou y prime of, that is y1 square, fine, which is equal to c, that is it is a composite function over there. Then this is y square root of 1 plus y1 square. I think that side the board is not visible, so I will write it here for you. Okay, so it is f minus y prime dou f by dou y prime is equal to 0. Sorry, after integration this is c, right? So this value of f is y inside the bracket, that is square root of 1 plus y1 prime square minus this is y prime dou f by dou y prime, it is y divided by that is 2 square, that is 2 root x, like, so 1 plus y1 square into dou by dou y prime of, that is 1 plus y prime square, which is equal to, that is c. So here this is y square root of 1 plus y1 prime square minus, okay, so this is y prime into y divided by 2 square root of 1 plus y1 square, and derivative if you are taking partial, so this becomes 2 y prime, right? Now this 2 and this 2 gets cancelled, right? So this y, and here it is, I hope it is y1 square, it becomes y1 square. So this is y, am I right? Yeah, square root of 1 plus y1 square minus this is y1 square y divided by square root of 1 plus y1 square equal to c, right? So see the solution, that is the total surface area, okay, when it is rotated, okay, this time I am taking x axis, so it is given by the integral I over x1 x2 2 pi, okay, into y, that is dx ds by dx, okay, along, that is dx. Now this is 2 pi y, so that is minimum length of the, that is arc length of the surface is always given by, that is square root of 1 plus y1 prime square into okay, y1 square. Now this, since 2 pi is constant, so the given functional is y into square root of 1 plus y1 square. Also we know that I am taking, for convenient purpose, I can also make use of other forms of Euler's equation. So it is d by dx of f minus y prime dou f by dou y prime minus dou f by dou x equal to 0. Since x is independent of f, sorry, f is independent of x, so this turns out to be 0. Therefore d by dx of f minus y prime dou f by dou y prime equal to 0. So on integrating, what do I get? So on integrating, so it is f minus y prime dou f by dou y prime equal to c. Now what is the value of f? Value of f is y square root of 1 plus y1 prime square minus y1. See here, this is, I am differentiating partially with respect to y prime. So if I am taking this equation, so y prime, it becomes 1 upon 2 root x, like, okay, it is composite function 1 upon, see, y I am taking, that is constant, that is 2 root 1 plus y1 prime square into dou by dou y prime of 1 plus y1 prime square, which is equal to c. Now y square root of 1 plus y1 y prime square minus this okay, when I evaluate y1 prime y divided by, that is square root of, that is 2 root 1 plus y1 prime square 2 y prime, it becomes this 2 and this 2 get cancelled, so you have left out with this particular thing, right? Now again what I do is, I'll finish. No, it's okay. Okay, so where I was, yeah. So here what I do is I will multiply this, okay. So here it becomes a y, and this square root, and this if I take so this turns out to be 1 plus y1 prime square minus this is y1 square y prime square, which is equal to c into, that is square root of 1 plus y prime square, right? So here it is y, which implies y plus y1 prime square into y minus y1 prime square into y, which is equal to that is c square root of 1 plus y1 square. Now these two terms get cancelled, and which implies y is equal to, that is c square root of 1 plus y prime square. Then what I do is I again square root, so this becomes y square, which is equal to c square inside the bracket 1 plus y1 square. So here still I have this derivative. I want my expression to be in the form of, as I said, y is equal to y of x. Sometimes the course with respect to the problem domain will change. It might be either in terms of time, it might be in terms of angles, that is some angle theta, right? So here this implies, that is y square is equal to c square plus c square y1 prime square, okay. Now this is, let me, yeah, so here this is, which implies y1 square is equal to, or here it is c square, so this turns out to be y square minus c square. So I am going to continue here. See, simplification part you can do it as per your convenience. This is, I am doing it step by step. Y prime square, which is equal to y square minus c square divided by, that is c square, fine. Now here again on squaring, if I square this, so I get y prime is equal to, that is square root of y square minus c square divided by, that is c. Now this in short, which implies this y prime, I can write it as dy by dx, right? So I can write it as dy by dx, which is equal to yes, correct, yeah, square root of y square minus c square divided by c, fine. And now so from here, so this here, this is dy by dx. So what I do is I can make use of see, this is dy divided by square root of y square minus c square, which is equal to, that is 1 by c into dx. So what form is this? See, it is as equivalent to, that is girls one side, boys one side, that is variable separable form, that is x terms one side, y terms one side, right? So that is dy by dx. So what, all y terms I have taken one side and the x term on the other side. Therefore this is, in the bracket you write variable separable form, fine. So when the variables are separated, what you do, you perform integration. So integration of that is dy by that is square root of y square minus c square, which is equal to that is 1 by c integration of dx plus I have taken b over here, okay, b. So this integration is cos hyperbolic inverse y by c, which is equal to x by c plus b. Fine. So finally what you get, that is the equation what you get is y is equal to c cos hyperbolic inside the bracket x by c plus p. So this is which is the equation of Catenary. So see here, whenever you have been asked to solve the any catenary problem, you will end up with this particular equation only. So this is a general interpretation equation of such type, right, with respect to all your variables, whether it is theta or any other parameter, right. So always you have which is the required catenary, right. So y is equal to c cos, this is c cos hyperbolic it is, right, c cos hyperbolic x by c plus b. Yeah. So this was all simplification. As I said, make use of take a that is functional, and then take whether whichever Euler's form is convenient for you, you can take it, and then you arise a ordinary differential equation, and then you apply, that is certain tools and techniques to evaluate it, right. So which is equation of Catenary, right. So let me have another okay, this is something descriptive, but you need not write it all the time descriptive. So fourth question, that is discuss hanging chain problem, hanging chain, okay, hanging chain problem. You can have like Howrah bridge. Some bridges are constructed with this concept only, right. Fine. If you do not know this concept of calculus of variation of catenary problems, then you cannot create a better bridge, right. Okay, fine. So discuss hanging chain problem. So I will write it for you. A heavy chain, a heavy cable hangs freely under the gravity between two fixed points. Show that the shape of the cable is a catenary. Okay. So what you do is, let me up. So question might be asked. So you need to write the description how you are going to solve a hanging chain problem, and see that the shape of the cable is a catenary, and then you will arise with this particular equation or the curve, solution curve. Fine. Okay. So let me draw this for you. Yeah, here only. So what I'll do is, I will take this surface x, this surface that is y, and what I do is I will take a point P and a point Q, okay, to which the cable is a heavy cable is attached. Okay, so this is my curve S. So I will take some element here. Okay, so if I take some element over here, so this becomes ds, and under the influence of gravity, so this is my y is equal to h, right? So please see that, discuss hanging chain problem. A heavy cable hangs freely under the gravity between two fixed points. So this is two fixed points, and it is hanged freely under the influence of gravity. Now this small element, okay, it might, that is surface of the element. So this it might be here, it might be here, it might be anywhere. So in general I am taking here some part. If I take here, okay, and this is the height, okay, that is influenced by gravity downwards. So show that the shape of the cable is a catenary, right? So let me write the description first, and then I'll explain. So let P be the point x1, I haven't written, that is x1 and y1, and Q be the point x2 and y2. Let P x1 y1 and Q x2 y2 be the two fixed points of the cable. Let us consider an elementary arc length ds of the cable. Now again let rho be the density, that is mass per unit length. So that rho into ds is mass of the element. Now if g is the acceleration due to gravity, then the potential energy mgh is given by that is mass g into h. And also what are we doing is, where x-axis is taken as a reference line. Where x-axis is taken as a reference line. Therefore, I need to find, that is the total. Okay, first time. Okay, so what are we trying to do is, we are going to find that is the given cable has a shape of a catenary, and which results in a equation of catenary, that is y is equal to c cos hyperbolic x by c, plus B, right? So what I do is I take 2 points, hang a heavy chain or a cable, you can say, and then under the influence of gravity. So these are the consideration. You can write it in your own words. There is no restriction. Okay, since it has been asked, that is you have to discuss it. So there is nothing such you need to mug up the answer. Just only in proper manner I have given. So let P and Q be 2 points, fixed points, and let us consider an elementary arc ds. So some element. So I'll take some element of this arc S, okay, of the cable. Let rho be the density, that is mass per unit length, so that rho ds is the mass of the element. So this including rho, it might be here, some part if I am taking here, some part if I take here, so it is, that is mass of the length, okay, of the element. If g is the acceleration due to gravity, okay, then the potential energy mgh is given by, so what is the mass? Mass is rho, that is density, that is mass per unit length, so some length into gh. Now where x is taken as a reference line. Now the total potential energy, so it is possessed, there is no movement, so therefore the total potential energy, I'm going to write PE, therefore the total potential energy of the cable is given by, that is the tension T. Okay, so at any instant you have a tension T here, okay, tension T is equal to, that is integration from P to Q, and it is rho ds into G by, okay, which is equal to, that is integration from x1 to x2 rho G y. So we are taking x-axis taking as reference, so this is ds by dx into dx. Now this is, which is equal to integration of, suppose this rho and G, okay, so rho and G will be, that is constant outside, and integration of, that is x1 x2, this is y. So what is this ds by dx? It is the curve, okay, that is arc length, so it is given by square root of 1 plus y1 prime square into dx. So you can write, since ds by dx is equal to, that is square root of 1 plus y1 prime square. Yes. So now this equation can be solved, okay, so which is equal to, so I am not going to solve this for you people. So previously that catenary problem, so your functional y, so it is one and same, only the thing is you should include rho and G, that is the factors which affects. So in the previous problem there were no factors, right, like density or the gravity under which it influences. Now it depends upon the density over here, okay. So whenever you are applying it for real time situation or problems, but here this is this equation you have solved, and to which you get cos hyperbolic, that is your output as y is equal to cos hyperbolic x by c plus b, where b is some constant you take, that is any value you can take, some parameter, okay. So this solve as previous, I will write solve as previous, so not a big issue, fine. Yes. Okay, fine. So let us, okay, so geodesic problems are over, catenary problem are over, then we shall see one more important and interesting uh, application, that is of calculus of variation, that is brachistochrone problem, right? So this problem is as interesting. So your pronunciation might be, you might be better than me. So brachist, let me check. It is B-R-A-C-H-I. Yeah, I missed the S. Okay, brachistochrone problem, right? So in this problem, okay, let me give you a task. Suppose two friends, okay, yeah, two friends, okay, let me consider myself and somebody else from this class, right? So in childhood you all have played seesaw, right? So what is the task? Now this is my point, that is I will take the origin, and this is some point I need to reach. This is my land, or that is the earth, and from here if I am having two ways, one is a straight line and the other one, okay, from, okay, I am possessing different weight. Let me take as 50 kgs and 70 kgs person. Okay, so if you take okay, sorry, not okay, I will take myself only, right? Okay, if I take this 50, if I travel, if I want to travel, okay, so what are the ways to travel from this position to this B? It might be this position, it might be this position, with respect to what? That is time, and under the influence of that is, I hope it is, yeah, okay, with respect to time, time taken by the particle to move from this part to this, and which is the shortest path, which is the shortest path that a particle can travel from one, that is position O to B, that I need to find, that is with respect to time. Okay, so this is all about that is brachistochrone problem, that is we find a path in which a particle, in the absence of friction, will slide from one point to the other point in shortest time. Okay, suppose this is my A, this is my B, and suppose what is the shortest time taken by the particle to move from A to B? It might be this path, it might be this part, it might be this part. Okay, so what is the time, shortest time taken by the particle to move from A to B? So do you have any guess? Okay, so obviously when I ask you a question, you will say obviously this particular straight line. Okay, so let us see, but I say that it is not always a straight line, but it is some other curve. So let us see what it is, right? So here I will not write the question, I will directly solve the question, that is output. So here it is, I will draw this figure for you, that is O, this is Y, sorry, X axis direction, and I need to reach from O to X1, Y1, and let my point be here. First I will give all the description and then I shall explain you in one go. Okay, so what I need to do is, I am taking this coordinate, that is X and Y, and I need to travel the particle traveling from this particular position to A, right? And let me check whether it possesses the shortest distance shortest it will travel with the shortest time, right? Okay, so right, let the particle